Hello friends, myself VV Golkar, Assistant Professor, Shellstone Technology, Ichalkaranji. Today in this video, we are going to discuss about evaluation of limit by using L'Hospital rule. So before that, first we will see what are indeterminate forms. So the first indeterminate form is 0 into infinity. So 0 into infinity we cannot define this one. For example, if I write 0 into 1 is 0, 0 into 2 is 0. That is any number into 0 is 0, but 0 into infinity we cannot define because we don't know what is infinity. Similarly, 0 upon 0 is also cannot be defined. Like that, infinity upon infinity it cannot be defined. Infinity minus infinity, 1 to the power infinity, 0 raised to 0, and infinity to power 0. So I will take one more example here. So I will take this one, 1 to the power infinity. So we know that 1 raised to 1 is 1. Or then 2 to the power 1 or 1 to the power 2 is 1. 1 to the power 3 is 1. So like that, 1 to the power any number is 1, but 1 to the power infinity, again the question is same, we don't know what is infinity. So these are 7 indeterminate forms. So today I am going to solve limits on 0 by 0 form. So first we will see L'Hospital rule. So the rule is like this: if f of x and g of x are two functions, then it can be expanded by Taylor series in the neighborhood of x equal to a. Here the point is what? X equal to a, and they are given if f of a equal to 0, g of a equal to 0, then as per the L'Hospital rule, see here carefully, limit of x tends to a, f of x upon g of x. So this is, let us consider, this is our problem. So if I put here limit, that is what? X tends to a, it becomes what? Limit of f of a upon g of a. So it is become, if I put limit here, it becomes f of a upon g of a. So what is value of f of a? That is 0. And what is value of g of a? That is 0. So it becomes what? 0 by 0. So here we cannot calculate the limit. To solve such type of example, we are applying L'Hospital rule. The rule is like this: if the limit of the given function is in the form of 0 by 0 or remaining indeterminate form, then the rule is like we have to differentiate numerator separately. See here, we have to differentiate numerator separately and we have to differentiate denominator separately. Again we have to put the limit. Again if the case repeats same, means again if we get 0 by 0, then we have to go for one more derivative. Again we have to differentiate numerator separately and we have to differentiate denominator separately. So here I have written provided the latter limit exists. The rule is simple here: if the given problem is in the form of 0 by 0, then we have to differentiate numerator separately and denominator separately, then we have to apply the limit. So now I will take some simple example based on 0 by 0 form. So first question, evaluate limit of x tends to 3 x minus 3 upon x square minus 2x minus 3 as x tends to 3. So here we have to evaluate this limit. Solution. So this is very simple example. Given limit of x tends to 3 x minus 3 upon x square minus 2x minus 3. So see here carefully. If I apply the limit, so what is value? X tends to 3. So if I apply the limit, numerator becomes 3 minus 3, that is 0. 3 minus 3 is what? 0. And denominator also becomes x square, that is 3 square is 9. 2 into 3 is 6 minus 3. Minus 6 minus 3 minus 9. 9 minus 9 is 0. So the given problem is in the form of 0 by 0. Therefore here you cannot evaluate the limit directly. Therefore what I do? So I will apply here by L'Hospital rule. L'Hospital rule. So what is L'Hospital rule? We have to differentiate. We have to differentiate numerator separately with respect to x and denominator separately with respect to x. Derivative of x is 1 minus derivative of 3 is 0 upon derivative of x square is 2x. Once again I will tell you, numerator we have to differentiate numerator separately and denominator separately. Derivative of x square is 2x minus derivative of 2x is minus 2 and derivative of minus 3 is 0. So this implies limit of x tends to 3 1 upon 2x minus 2. So now again I will apply limit. So limit is x tends to 3 here. So once I will apply limit, 1 is constant here. I will write as it is 2 into 3 6. 6 minus 2 is 4. So this is our required answer. So I will take one more example. Limit of, so example number 2, x tends to 0 sin 3x upon sin 4 into x. Solution given limit of x tends to 0 sin 3x upon sin 4 into x. So I will apply the limit. X tends to 0. Put x equal to 0 here. 3 into 0, 0. And we know that the value of sin 0 is 0. Sin 0 value is 0. Again same in denominator also. Put x equal to 0. 4 into 0 is 0. And sin 0 value is 0. So this is in the indeterminate form. So for that what I do? I will apply L'Hospital rule. By L'Hospital rule. So this implies limit of x tends to 0. As per L'Hospital rule, we have to differentiate numerator separately and we have to differentiate denominator separately. So numerator is sin 3x. Derivative of sin 3x is, derivative of sin is cos 3 into x. Now sin is removed, remaining is 3x. Derivative of 3x is into 3 divided by. Again derivative of sin is cos. Now cos sin is removed, remaining is here 4x. Derivative of 4x is 4. So this implies 3 upon 4 constant. So I will write outside the limit of x tends to 0 cos 3x upon cos 4x. So again I will put the limit. So this implies 3 upon 4. So put x equal to 0 here. 3 into 0, 0. And cos 0 value is 1. So the numerator is 1. Put x equal to 0 here. 4 into 0 is 0. And cos 0 value is 1. Divided by 1. This implies 3 by 4. So this is our required answer. So evaluate limit of x tends to 0, 3 to the power of x minus 2 to the power of x upon x. Solution: given limit of x tends to 0, 3 to the power of x minus 2 to the power of x upon x. So again, orally I will put the limits and I will verify. X equal to 0, I will put x equal to 0 here. 3 raised to 0, it becomes 3 to the power of 0 minus 2 to the power of 0 upon 0. So 3 raised to 0 is what? 1. Any number to the power of 0 is what? 1. 1 minus, again 2 raised to 0 is what? 1. 1 upon 0. So this is what? Again in the form of indeterminate. So therefore, to solve this limit, I will apply what? L'Hospital rule. So by L'Hospital rule, this implies limit of x tends to 0. See here, we have to differentiate 3 raised to x. So we know that derivative of a raised to x. Derivative of a raised to x is what? A raised to x into log of a. So here we are having 3 raised to x. It becomes 3 to the power of x into log of 3. So we have to differentiate numerator separately. Minus derivative of 2 raised to x is 2 raised to x log of 3 divided by derivative of x is 1. So this implies, now I will apply the limit 3 raised to 0, 3 raised to 0, I will put x equal to 0, log 3 minus 2 to the power of 0 log 3. So this implies 3 raised to 0 is 1, remaining is here log 3 minus 2 raised to 0 is 1. So this is what? Sorry. So this is 2. Log 2. So this implies log a minus log b. We know that log a upon b. So this is our required answer. So we'll take one more example on this. Evaluate limit of x tends to 1 plus cos pi into x upon x square minus 3x plus 2. Problem number 4. Solution: given limit of x tends to 1 plus cos pi into x upon x square minus 3x plus 2. So again I will calculate the limit orally. I will put x equal to 1 here. 1 plus, here this becomes cos pi. I have taken x equal to 1 here. Remaining is cos pi. Denominator 1 square is 1. 1 plus 2 is 3. 3 minus 3 is 0. So this implies 1 cos pi value is minus 1 upon 0. So this is what? 0 by 0. Cos pi value is 0. So again this is in the indeterminate form. So therefore by L'Hospital rule, by L'Hospital's rule, limit of x tends to 1. So derivative of 1 is 0. Derivative of cos is minus sin x into derivative of pi into x is pi is constant here. So x is 1, remaining is pi. Divided by derivative of x square is 2 into x. Derivative of minus 3x is minus 3 and derivative of 2 is 0. So this implies limit of h tends to 1. So minus I will take outside the limit and pi is also constant. I will write outside the limit. So remaining is here sin pi into x upon 2x minus 3. 2x minus 3. So this implies minus pi. Now I will put the limit as x tends to 1. So remaining is sin pi and sin pi value is 0. So the value of sin pi is 0. 2 into 0 is 0. 2 minus 3 is minus 3. 0 minus 3 is minus 3. Pi into 0 is minus get cancel. 0 upon 3 is equal to 0. So this is our required answer. So in this video we have seen what are the 7 indeterminate forms and we have seen L'Hospital's rule and we have solved problems on limit by using L'Hospital rule. Thank you.